just don't want to have to do weekend.
I totally hear that.
I
don't
it's
blame
an
you.
option. I just don't want to.
Yesterday, like literally, I think might have been the best day of my entire life. No, I'm serious. I was like, because Wednesday I was like, okay, I gotta get this done. So I did a bunch of schoolwork, put together some stuff for you guys, shoveled for 3 hours, right? Because our street does not get cleared. So me and all our neighbors, we all clear our street, right? Anyway, and then the next day, because I thought we were going to have school, because I looked out at the roads and I'm like, you know what, if I shovel my street, I can get off our street. And then if I can get off our street, I can get here. So surely it's not going to be canceled. So I got up early, I shoveled again. And then at 6:30, it was like, no school. And I was just like, and I was like, maybe I should do something today. And then my brain said, no, you are so tired. I didn't really actually get like a break this Christmas because like the Christmas break because I had some personal stuff going on. But like I was like, so I didn't get that day. You know the day when you just sleep and you do nothing? I got that day. And it was a surprise that I got it. So you know, like there's nothing better than a surprise day when you don't have to do anything. Is it good? So good. Anyway, I'm still on a little bit of a high from that. I'm like, ah! Anywho. All right, so here we go. Quantitative aspects of electroplating. So you might be asked to determine the amount of metal that is plated onto the cathode in a certain amount of time. You might be asked what the amount of time is, or other similar questions. And in order to do this, you need to be able to use your AP data sheet. That should have a T at the end. Fix. Okay, so the ones that we are looking at in particular on your AP data sheet for this particular worksheet are I equals Q over T. Are you guys familiar with that formula, maybe from physics? No, okay. Do you know what I stands for? Current. Do you know what Q stands for? It's the same thing as charge. Okay, and little t is? Time. Okay, so current equals the amount of charge passing a point. So it's the charge passing a point in 1 second. Is good? So you need to be able to calculate that. Now, what do you need from the right-hand side? Well, if you forget what any of those things mean, you can look over here and you can say, oh, look. I is current, Q is charge, it's measured in coulombs. T is the time in seconds. And Faraday's constant tells you the coulombs per mole of electrons. Now, what do you think you could use coulombs per mole of electrons for? Whenever you have a per, you can probably use that as a conversion factor. You might also have to use 1 volt is equal to 1 joule per coulomb. That would also be a conversion factor. Okay. Now, this is just reviewing a few electrical concepts for you. Charge, Q, is measured in coulombs, C. A coulomb is the amount of charge in 6.24 times 10 to the 18 electrons. You do not need to know this number for AP chemistry. Okay, you just need to know, I tell my grade 9s, a coulomb is a bucket of electrons. Okay, it's kind of like the mole of the electricity world. Okay. Current is measured in amperes, and amperes is the amount of charge per unit time. So I equals Q over T. So 1 ampere is equal to 1 coulomb per second. And this can be used as a conversion factor, okay? So if you had 3.5 amps, you could say you have 3.5 coulombs per second. So that allows you to take coulombs and turn them into seconds, or seconds and turn them into coulombs. Is good? Okay. Faraday's constant. Again, this is going to be a conversion factor. We looked at it on the previous page. And basically what it does is it combines the fact that in 1 mole of electrons, we have 6.02 times 10 to the 23 electrons, yes? And 1 coulomb, so we've canceled out moles of electrons. 1 coulomb is 6.24 times 10 to the 18 electrons. So what we're left with is that 96,500 coulombs is what is equal to 1 mole of electrons. And that's going to allow you to convert between coulombs and moles of electrons. But that is the one that is given to you on the data sheet. Let's go back and look. There it is right there. Okay, 96,500, except for they usually go to more decimal places, 96,485. Okay, so use that entire number. I have probably used 96,500 because that's what they used to use on AP. And so if I've used the wrong value, then we might have a little bit of differences in the final answers. All right, so for example, here we have, and this is all written down for you, so you can either write this yourself or you can just watch and assume that it's on the page for you. If we have a current of 2.50 amps, so I is 2.50 amps, and if it is run through a solution of iron 3 chloride, FeCl3, for 15 minutes, so T is equal to 15 minutes. What is the mass of the iron that would plate out? And that would be measured in grams. Now, do you remember what an amp is? Okay, so we're going to go to our sheet. Okay, so we're going to go to our equation sheet. Do we have the AP equation sheet? No, we don't. Yes, we do. There it is. Okay, so on our AP equation sheet, we are looking here, and current is equal to Q over T. If current measured in amps is equal to Q over T, what's another way we can express amps?
Charge over time.
Charge over time, okay? What is the unit of charge over time? Charge is coulombs, and if you don't remember that, you can look over here and say, what is charge it's in? Coulombs. Right, so I is in amps. So we've got I is in amps. Q is in coulombs. And it says over here that Q is in coulombs. And T obviously is time. And what would we be using for time? Because we're going to use SI units, seconds. So by doing that, that allows you to know that amperes is equal to coulombs per second. And that's going to allow you to convert between coulombs and seconds. Sorry, I've gone way past where I meant to. Whoops, there we go. Okay, so we're going to rewrite our current. Instead of amps, we're going to write it as coulombs per second because now we have a conversion factor. We want to find the grams of iron. Yes? I would like you to see if you can come up with a map of what you would start with and what you would convert each thing into. So you have to start with one of the numbers you are given. You're given two different numbers. Which one do you think you'll start with? Will you start with 2.50 coulombs per second, or will you start with 15 minutes? 15 minutes, because the other one is a conversion factor, so we're going to be multiplying it. So start with 15 minutes and see if you can figure out what you'll convert it into and find the whole chain to get to grams of iron. Feel free to use your AP sheets. Minutes to seconds? Is that a good start? Okay, good. And don't forget, you've got Faraday's constant. Which you can also use as a conversion factor. So once we've gone from minutes to seconds, we can use coulombs per seconds to go from seconds to coulombs. Yes. Yes. Of course. So minutes to seconds, seconds to coulombs, coulombs to moles of electrons, to moles of iron, to grams of iron. So we're going to have a 1, 2, 3, 4, 5-step conversion. "15 minutes times 60 seconds per minute times, cancel seconds and find coulombs, 2.50. coulombs per second. 96,485 coulombs per 1 mole of electrons. Nope. That's upside down. I need my coulombs on the bottom. 96,485 coulombs per 1 mole of electrons. Now, how do we know the moles of electrons per moles of iron? We need the half reaction. So we are turning Fe. Yes. I would. Yes. Whoa, watch how long it takes me to do it. Fe3 plus 3 electrons gives Fe. That took me, what, 7 seconds? Such a waste of time. Oh my God. Okay. Anyway, so we have 1 mole of Fe for every 3 moles of electrons. And then we go find our mass of iron, which is, I don't know, 58.5. You'll have a number with more sig figs on the AP exam. Use the number with more sig figs. Yeah, it doesn't matter. 55 point, what was it? 8. Okay, grams per mole. Do we need to do the calculation or are we good? We're good? Okay, excellent. Let's try the next one. An electrolytic cell is constructed. So electrolytic, spontaneous or non-spontaneous? Non-spontaneous. It is constructed in which electrodes are placed into an aqueous solution of CuSO4. Aqueous. We have a current. What's the symbol for current? Current is, the symbol for current is I. And if you forget that, you go back here and you say, what's the symbol for current? It is I, okay? So no worries if you can't remember, you just have to go look for it. So I is equal to 3.00 amps. Now, what are we probably going to want to do with those amps? We probably want to write it as, what's the other unit we can use for amps? Coulombs per second. If you forget that, where will you go look? You will go look on your data page and you will say, I have I measured in amps over Q measured in coulombs per time measured in seconds. So an amp is a coulomb per second. Yes? And if you forget what all of those things are measured in, it says over here, current is measured in amperes, charge coulombs, time seconds. All right. How long, if they're asking how long, what is our unknown quantity? Time. So time is what we don't know. And that's going to be in what unit? Seconds. Must the electrolysis proceed in order to plate 5 grams of copper? So that's the mass of copper is equal to 5.00 grams of copper. So what I'd like you to do is I'd like you to figure out what we're starting with, what we're finishing with, and then write a conversion chain with some arrows, just like we did for the last one.
Then you took Faradays, whatever. Yeah. It was so fun. I'm gonna fail you. I like to think I can.
Oh, I just studied the whole. No, not. I can't even say the whole thing. I won't. It's like. It was too detached.
Last year was.
Yeah. Math on but
That's really
what is their cost to each other? Well, are you just there for you still not on there?
You guys can check your work. What do you think? Did you get what I got? Grams to grams of copper to moles of copper to moles of electrons to coulombs to seconds. And then we have grams of copper cancel out. Moles of copper cancel out. Moles of electrons cancel out. We're using Faraday's constant here to go from moles of electrons to coulombs. And then finally, we have to turn the current upside down to get it to convert from coulombs to seconds. Yes?
Okay, did that like all of the shoes at home?
Uh-huh.
You got 96502.
Yeah, and that's because I probably from like, it used to be on the AP sheet as 96500, but now it's using 96485. So just use whatever you're given on the exam and you'll be fine. Okay? Yeah. Do you guys think you could do this one? We have a mass of silver is 10.8 grams. We want to know the current. We don't know how many amps. And remember, if we're talking about amps, what we're really talking about is coulombs per second. And the time is equal to 5.00 hours. Now, I'm going to tell you, you don't want to write this, amps equals coulombs per second, and use that as a formula. Because that is not the formula. What is the formula to find current? If I told you, please give me the ideal gas law, what would you tell me? PV equals nRT. Would you tell me that the formula is atmospheres times liters is equal to moles times liter atmosphere per mole Kelvin times Kelvin? Is that what you would do for the formula? No, because that's not the way we give formulas. We give formulas using the quantity symbols, not using the units. So I is equal to what? Q over T, because that is given to you. So you want to, if you're going to use that formula, write it like that, and then substitute in your numbers with the units.
Oh. Yeah, you don't need a finding. This I watched you guys. Was it? You didn't look at that right yesterday. No, either way. Hey, think about it. Yeah, it's like, but he did say that you did not. Why did you do Oh. But you didn't really participate in any conversation except for the conversation, you know. Yeah, so then. They think part of the. Well, rarely, unless like I talk to him. Okay. He was not a top. Oh, Aaron. He was always. Yeah. I don't. Yeah, this guy got beautiful. It's still honestly. Hey, we're getting DC out of the shell. How about we have this high part that go on the outside of the confidence? Need a soft part? Yeah, it's soft.
Did you guys get 0.537 amps? Yes? Excellent. So that's basically it for those. So as long as you can remember your coulombs per second and to use that Faraday's constant, it's just conversion factors and maybe using this one little formula here. Okay, so it's not hard. You just need to remember a couple little things. All right, next, Gibbs free energy. Page 146. Now, I realized this morning that the one thing that this did not cover was using K with E0 cells. So we're going to do that at the end. It's not actually in your book, but we'll do it. Okay? So the key equation is this one. Is this on your data sheet?
Yeah, I did.
Look what we have here. We have delta G is equal to NF E0, negative NF E0. Yes? So that's the first one we're going to use. But it also means that if delta G is equal to negative RT ln K, then delta G is equal to negative NFE. Therefore, RT ln K is equal to NF E naught. Yes? So if you needed to, if you were given a K value, you could find the E naught value, because E naught would equal RT ln K over NF. Okay? Also, if you're given an E naught value, you can find K. Ln K is equal to NF E naught over RT. Now, you can simplify that if you want to by saying that K is equal to little e to the NF E naught over RT. Yes. K is the equilibrium constant. Now, one thing I did notice is that they actually do give you the Nernst equation here. But I also noticed when they wrote one of the questions last time, they were like, without doing any calculations, show what happens to, or describe what happens to the E naught when you increase this concentration. So you need to be able to do those descriptions without using the Nernst equation. But you can look and be like, okay, you can kind of use it to jog your memory. Yes? That's right, yeah. Because even though they give it to you, it's not an expectation that you be able to use it. I know. So confusing. Well, you know what? The other thing is too, though, that they actually don't necessarily expect you to be able to use, where is the one? The Henderson-Hasselbalch equation. But it is the nicest equation you're ever going to come across, right? Like in terms of just being able to calculate the pH of a buffer. And that's going to be one of the things that we cover next week on Thursday. Okay, is there anyone who is taking the AP exam who cannot make it next Thursday? Okay, you need to watch the recording then, okay? And I will post whatever things I give out on Teams, but if you're in the building before Thursday that week, I'll also have copies of them starting on Monday, so you can drop by and pick them up if you would like to, okay? If you happen to be in the building, say, writing your assessment or whatever, okay? All right. So what was this all about? Well, if delta G is positive, because this has a negative sign here, if delta G is positive, that means E naught cell is negative. If delta G is negative, E naught cell is positive. And what should we be writing here instead of non-spontaneous? Thermodynamically unfavorable. Oh, AP, why do you choose such long words? Thermodynamically favorable. Okay, we're going to skip over this. Skippity skip. Skippity skip. Okay, other things you might need to know for this section is that a volt is equal to a joule per coulomb. Yes?
Is oxidization a word?
Oxidation, not oxidization. Yes. Oxidation reduction. Yes. So nothing new, just use your sheet. Let's take a look at a couple of examples here. We have lead 2+ going to lead neutral. That means that this equation is going this way. Nickel goes to nickel 2 plus. That means that the top reaction is going that way. So these are written in the order that you would find them on your data sheet. Is this an electrochemical cell or an electrolytic cell? Oh, actually, they aren't written in the order you would find them. Nickel is below lead. Yeah. Whoops. Silly me. So anyway, nickel should be below lead. All right. And so you could use either lead being reduced. You've got your reduction at the cathode. You can either do the reduction potential of nickel at the anode or the oxidation potential of nickel. Regardless, we have E naught cell gives us plus 0.13 volts. Any confusion on how we get that? Good. All right. You have a positive E naught cell. A positive E naught cell means that the reaction is spontaneous. What is the sign of delta G? Negative. Now we can calculate delta G. Nothing special. Just grab that formula and toss some numbers in. The only thing you have to know is, how do I find N? Well, when I add up my two reactions, I always need to make my electrons in equal my electrons out. Whatever that total number is, once you've finished multiplying, here we did not have to multiply, whatever that number is, that is your value of N. Okay, so let's say we had Al 3 plus 3 electrons gives Al, and we had Fe, oh, I don't know, 2 plus? No. 3, 2, yeah. 2 plus, no, goes to Fe, 3 plus an electron. Just say that's what happened. Yes? Actually, no. Let's say that those were our two half reactions, aluminum and iron. What would we use for the value of N, the number of moles of electrons? Are we good with the fact that it's 6? Excellent. Okay. So that's the value you use for N. F is just Faraday's constant. And you should remember that a volt, remember your E naught cell is measured in volts. That is a joule per coulomb. And if you forget that, guess what it says over here? A volt is a joule per coulomb. And that's going to be handy because you're going to want delta G in joules, because delta G is an energy. It is measured in joules. All right, so we say we have negative N, this is N, F, E naught cell, but we've changed volts to joules per coulomb. All right, and so our moles of electrons cancel with the moles of electrons. Our coulombs cancel with our coulombs, and we end up getting joules. Okay, now you might be asked to do something with this later, so you might need to change it into kilojoules, because very often if you're then asked to work with a delta H value, it will be in kilojoules. Just be good at converting between kilojoules and joules. Okay? And that, I think, is all I gave you on there. So I'm going to give you a new sheet, which I put in here somewhere. Here we go. Okay, I got 3 things for you today. So I'm clearing this out. if you are writing AP and you have not yet taken one of each of these things, you should do that. And I'm going to put this over here so it's not confusing. So that's the old stuff, the health and self control stuff if you've not yet taken it. The new stuff is here.
We got one and it was.
So there's like a million things here to find each.
Yeah. We have to talk everything.
Yo, what do I do?
What grade?
You don't have to do a fly.
Oh, it's here. Oh, yeah.
Right? Stick around with a few.
No, you have to do so it will look like that, but it won't be like. We got these last week. All of them were last week.
What if you replace it in your read essays?
I love the only one. I mean, honestly,
More excited now. What does that have to do? I don't know.
Hey, I did don't apologize.
Okay, I would like you to go to
That's not our fault.
the one that looks like this at the top. This one I honestly threw together this morning, so it's not very good. It says free energy and equilibrium, maybe a little bit down the page. There's one of the ones from that counter there.
Oh my God, how the hell?
So everyone make sure you got the three things from under the periodic table over there. Now, why don't I have, let's go find. Did modify. There we are.
But it's crazy. So every.
Okay, so what you've got here is you've got this one that looks like this. Yes? Am I not plugged in? Oh, for goodness sake. I plugged you in today. Thought I did. Oh, it's because this is not plugged in. Maybe it is. I don't know, I can't tell. Why are you not plugged in?
Like you can leave one way.
There we go. Okay. So questions relating E naught and delta G are on the first page. So these would be practice for what we just learned. And then on our next page, we have stuff that I haven't actually taught, but we should be able to do. So let's take a look at number 57. Would you be able to solve number 57 on the second page? Using the formulas given. So you can even just go up here because the formulas, I've written them down here. Try solving number 57.
Okay, what's that?
Oh, welcome on the lane.
What about this is ourselves?
In service.
Currently are don't know how to do this test myself. Oh, it is. Everyone comes on board. Since Jeremy got it wrong, I didn't think it was. You know, understand this vacancy for a ride. No one has a way of getting up the hill. Please, bro.
It's like,
How are you getting home? I'm not. That's why I didn't really have a way. Oh. Because you guys didn't go like on Thursday, I was like, I didn't see like Calvin very tall man. You were like, no, I didn't think you know. Okay. Oh yeah, maybe back. Oh, she definitely does. Yeah, this people do.
Oh, hang on. I guess we have to assume we're at 25 degrees Celsius since it doesn't say.
Oh my god.
But what value of R are you going to use? Oh, let's go check. Where are our R values? Oh, they're up here. Look at that. Which R value would you like to use for this equation? 8.314 because we've got units in joules and moles and Kelvin. Okay? 8.314 joules, moles, Kelvin.
No. I can't do that though, because I might CLC video to keep this on. Oh, so I'll probably oh, you're looking at multiple lines. You have graduation. Oh, they probably use. I was thinking about this is my account. No, you can replace all
Now let's see, did I do it right?
Why is it back?
Aha! So I got K is equal to 154.6, and I said, wow, which of my answers is that closest to? It's closer to 162. What might be causing that difference? maybe instead of 9645, we use 96,500. And that is indeed the case. I get 163 if I do it with 96,500. So because it's a multiple choice question, it won't really matter. Is good? So again, these kind of questions are mostly about being able to figure out the number of electrons transferred and just being able to use your formulas and being able to take these two formulas and combine them into one. Okay, so a lot of just formula sort of stuff. You still need to know which is thermodynamically favored, unfavored, all those things. And that's it for electrochemistry. So next week we will just have to learn. Yay, we're done, you guys. We're almost done. We need to learn about like buffers and polyprotic acids, and that's it next week. I would recommend, if you have time this week, literally, let's see, 23 minutes twice, so that's 46 minutes plus 9 minutes is 55 minutes. That's how much time you should give yourself to do these 3 questions. Okay? So do these 3 questions. The answer key in the chief reader's report is there. So you've maybe got a couple hours of chemistry for you to do. And if you're like, I'm not going to, well, I can't make you, so, you know, whatever. If you don't get them done, I don't know. You have to write your exam at some point, so not my problem, really. Your problem, not my problem. Yes? Now, oh yeah, what should we do in terms of review stuff for next semester? Because I know you have full timetables next semester, so you're not going to be like, yes, I want to study chemistry all the time. And yet, we have to study chemistry at least a little bit all the time-ish. So I could provide you with weekly reviews, just sort of smallish ones.
Yeah.
Right? Just so it's not like too much all at once. Would you like question reviews? Would you like videos from AP Classroom recommended to you? What would you like? Questions? Practice AP questions. I can do that for sure. Okay, so maybe I'll either give you a free response or I'll give you like, you know, 15 multiple choice or something like that. Yeah?
Maybe I don't think it's good at 6, but it helps you like it's like first give us the practice safety questions from like 1 and you know what I mean?
I have them all sorted by topic. So what I can do is, I mean, I can give you like the whole shebang and then I can just be like, okay, this week we're doing blah. Yeah? Okay, so pay attention to our team. I won't turn off our team until we're done the exam. All right, and if I say there's something for you to come and pick up, I will probably try and put it on the chair outside the door. So like if the classroom is closed, you can still pick it up. Okay, but I'll let you know when that's happening. I'm so excited I have to give you guys a comment and it has to include things you can do for the future. So all of you for the future, it's all going to say, continue to do the weekly reviews until the AP test. Now, if you're not taking the AP test, I apologize that that's what your comment is going to say. Also, we are being required to write an individual comment for each and every one of you that has to be unique and special, like each one of you. And I'm like, I could be making you guys review material, or I could be spending my time doing that. So what I'm going to do is I'm going to come up with one generic, lovely comment for all of you, and then I'm going to throw it into ChatGPT, and it's going to so that way we can focus on doing chemistry rather than writing something super meaningful to you. If you want to know what I think of you, like generally, just come and talk to me and I will tell you what an amazing person you are, because each and every one of you really are. Like, I really do believe that, but I'm not going to write it down, okay? Because my brain will explode if I have to do that. Oh, I'm going to have to yeah. Yeah. Here, let me just turn that off.
Wait,
Stop!